Hello friends, welcome to the video in which I'm going to take this topic isomerism in carbohydrates, right? So first point that for isomerism we should be having chiral carbon in the compound, chiral or asymmetric carbon. When all the four valencies of carbon are different, are occupied by different atoms or group of atoms, then that is called chiral or asymmetric carbon, right? So isomerism is of two types, structural and optical. Isomers are compounds having same molecular formula but structure is different or optical properties are different, right? If structure is different and same molecular formula, then that is structural isomerism. If same molecular formula and they have different optical properties, then it is optical isomerism. Be careful that capital D, capital L isomers are structural isomers. On the other hand, small d and small l, dextro and levorotatory isomers are optical isomers, right? Now, structural isomerism has further four types. Which are these? First is functional isomerism, in which the functional group is different. What are the two functional groups in carbohydrates? They are aldehyde or keto, right? So, if a compound has aldehyde group but the other has keto group, that is called functional isomers. Example, glucose and fructose. Glucose is having aldehyde group, fructose is having keto group, right? So, they are functional isomers of each other, right? Then second is enantiomerism. They are also mirror images of each other and they are capital D, capital L isomers. Now the definition here is that in this enantiomerism, the isomers have different H and OH orientation around the penultimate carbon. You can say second last carbon, right? This is also called reference carbon. For example, in case of glucose, second last carbon is C5, right? C5. So at C5, if OH is on right hand side, then it is D-glucose. But at C5, if OH is on left hand side, this is L-glucose, right? Then third is epimerism. Here isomers have different H and OH orientation around only one carbon other than penultimate carbon, right? Example, glucose and mannose are epimers of each other and they differ in only one carbon, that is carbon number 2, right? Then the last one, anomers, which exist in cyclic structure. Example, we have alpha and beta anomers. Here, the isomers have different H and OH orientation around the functional carbon, right? That is around the, either it can be aldehyde or it can be keto. In the cyclic structure, if OH is downwards, at the functional carbon, then it is alpha isomer. And if OH is upwards, at the functional carbon, then this is beta isomer, right? This is it. Thanks for watching. Best wishes to you.